So the alkynes. So the alkynes are the hydrocarbons which are unsaturated hydrocarbons because there are the carbon-carbon triple bonds will be present over here. So the general formula for the alkynes is CnH2n minus 2. So their names and all end with the YNE, ethine, propyne, butane, like that. And the members are as follows here. So the first member of the family is the ethine because there is a no methane. So because at least it needs three bonds to make the compound, but here in the methane we are having only one carbon atom, so it cannot able to make the triple bond. So the first member of the family is the ethine. So here in the general formula we have to substitute N equal to 2. Then we will get C2H2 and N equal to 3, C3H4 and N equal to 4, C4H6. So suppose if you want to write that N equal to 6. So what is the formula for the ethine, which is N is having a sixth number? So C6H. So we have to substitute 6 over here. So it is a, yeah. So C6H10. So this is the general formula for the carbon which is at 6. So C2H2. So now here C triple bond C. So now the C is making a triple bond with the carbon atom. So the single bond with the hydrogen atom over here. And the carbon is making a single bond with this hydrogen atom. So it makes the 4 bonds over here. Next to propyne C3H4. So it is a C single bond, C single bond. See, we have to write like this way. And the triple bond means we have to write like this way. And we have to balance. So here 1, 2, 3, 4. So this carbon is balanced. And here 1, 2, 3, 4. So this carbon is balanced. And here there is only one bond over here. So we have to make the 3 bonds like this. So butane also in the same way. So C4H6. So we have to write carbon, 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 the 4 carbon in a straight manner. And we have to write the triple bond between the first and the second carbon. And then, so the carbon already made the 3 bonds over here, the 1 bond with the hydrogen atom. So this carbon is already satisfied with the 4 bonds, 1, 2, 3 and 4 over here. And the next carbon is having 1, then 2 here, 3 here and 4th one. And this carbon is also having the 4 bonds with over here. So we have to write like this. We should not write the three bonds all over the carbon atom. We have to write only the between the first and the second carbon atoms. Chemical properties of the organic or carbon compounds. So what is meant by chemical properties? So how it is reacting with the other elements or the other compounds, that we call it as a chemical properties. So how it is react with the oxygen, how it reacts with the water, or how it reacts with the halogens. So that we call it as a chemical properties. So combustion reactions. So combustion means it's burning in the air. So the carbon compounds usually burns in the air to form the water and the carbon dioxide. As I said, so the LPG contains the propane and the butane. So the propane and the butane are the alkanes, which are C3 and C4 carbon atoms, which we are using in the LPG, liquefied petroleum gas. Nowadays we are using the cylinders, right? So when we are burning in the burners, so we will be getting the carbon dioxide and the water vapor as the byproduct. So it is safe to use. So here the carbon plus oxygen, we are getting carbon dioxide plus heat plus light. So CH4, so only one carbon atom is present, so it is a methane. So when we are burning the methane in the oxygen, so we will end up with carbon dioxide and the water plus heat plus light. So as it is a burning reaction, it will give a lot amount of the heat as well as the light. So we have to balance the equation. So one carbon here, and there are 4 hydrogen atoms are present. So we have to place the 2 in front of the water. So in here we are having a 2 oxygen atom and 2 oxygen atoms, so totally 4 oxygen atoms. So we have to place the 2 O2. So why we have to write the oxygen in terms of O2 means, so oxygen is a diatomic molecule. Whenever we are writing the oxygen, we should not write with O, single atom. We have to always write the O2. It's a diatomic. So C2H5OH. So now OH is there, so definitely it is an alcohol group is present over here. And C2. So there are two carbon atoms are present over here. So this is the eth one. This is eth one. So this is the ethanol. Ethanol. So OH is there, so we have to write the OL. There are two carbon atoms are there, so it's a eth ethanol. So ethanol, alcohols will also, the spritz lamps and all we are using. So in that we will be using the ethanol. So we have to burn in the presence of the oxygen. So same thing, carbon dioxide and the water vapor we will be getting. So we have to balance the equation. There are two carbon atoms are present. So here two CO2, and there are 5 hydrogen atoms and one more hydrogen. So totally 6 hydrogen atoms are there. So we have to write the 3H2O here. 3H2O. And now we have to balance the equation of for oxygen. So here 3 oxygen and the 4 uh, 4 oxygen. So totally 7 oxygen atoms are present. So here we have to place the 3 O2 and one more oxygen is present over here. So this is a 6 3 2. So this is a 6 over here and this is a 1. So totally 7 oxygen atoms are present. So now we have balanced the equation. The next one is oxidation. So oxidation means, so now there is a difference between the combustion reaction and the oxidation reaction. Okay, so the combustion means we are burning in the presence of the air. Air contains the oxygen, so O2 we will be getting directly from the air. Oxidation means, so we are using some oxidizing agents. So that agents, so example alkaline potassium permanganate. So the formula is KMNO4. Acidic potassium dichromate. So K2Cr2O7. So now these are all the two oxidizing agents which supply the oxygen atoms for the reaction. Okay. So we should not write the O2 for this oxidation reaction. This is a wrong. We have to write simply alkaline KMNO4 plus heat, or else we have to write, we should not write these two at all. Only one we have to write, either this one alkaline KMNO4 or acidic K2Cr2O7. Either we can use any one of the thing. And so C2H5OH. So C2H5OH is again ethanol because it contains the OH group. OH is a ethanol. So when we are supplying the oxygen atom, one water molecule will be removed. So here actually we can write like this way. The ethanol is CH3 CH2OH. So this KMNO4 or the K2Cr2O7 will supply the two oxygen atoms to us. Two oxygen atoms. So we should not write the O2. So two oxygen atoms it will supply. So what it will do? One oxygen atom will combine with this H2 and it forms the H2O. So plus H2O will come over here, plus H2O. So one more oxygen is left out over here. So that will be add up with this carbon atom and it forms the COOH. And it forms the carboxylic acid group. So C2H5OH, ethanol, when we are treating it with the acidic potassium dichromate or alkaline KMNO4, these two will supply the two oxygen atoms. So one oxygen atoms will combine with the H2 and it forms the H2O, and another oxygen atom will combine with this carbon and it forms the COOH. I will give you one more example. Suppose if you are taking the propanol. Propanol is having the three carbon atoms CH3, CH2, CH2OH. So now we are treating it with the KMNO4. So now it will supply the two oxygen atoms. So what it will do, so this hydrogen will be removed with the one oxygen atom and it forms the water, and another hydrogen oxygen atom will replace over here. So it becomes CH3, CH2, then COOH. So the acid group is present and 1, 2, 3. So there are three carbon atoms are present. So the name of the acid is propanoic acid. Propanoic acid. So when we are doing the oxidation, the alcohols will be converted into the carboxylic acid. Okay. The next one is the addition reaction. So what is meant by addition reaction is, so we are adding the two reactants and we will be end up with the only one product. So that we call it as the addition reaction. Unsaturated hydrocarbons. So unsaturated hydrocarbons in the sense either it may be alkene or the alkyne. So that's why we call it as unsaturated hydrocarbons undergo the addition reactions usually because they are having a double bond. So we can break the one bond and we can add the two atoms on both sides of the carbon atoms. So usually the unsaturated hydrocarbons undergo the addition reaction with hydrogen in the presence of the nickel or the palladium as a catalyst. Okay, what does mean by a catalyst? So the catalyst is nothing but it is just a speed up the reaction. So why we are particularly adding the catalyst for this addition reaction is because so in this case hydrogen is also the gas and the whatever the ethene we are using, so that is also the gas. So the two gaseous molecules are moving randomly. So that's why we have to add the catalyst. So then only they will collide each other frequently and we will be getting the product easily. So that's why we are using catalyst for this addition reaction. So when we are adding the hydrogen to the unsaturated hydrocarbons, so we will be getting the saturated hydrocarbons. So unsaturated, we are converting it into the saturated hydrocarbons. Okay, so now we are taking the example ethene. So this is the formula for the ethene, C2H4. So we are writing the formula as C double bond C. So H here, H here. So now the carbon is having the four bonds. So now it's fulfilled. We are adding the hydrogen gas. Either the nickel we can write it or the palladium we can write it over here. We are using it as a catalyst. Always the catalyst we have to write in above the arrow mark. Now next one is, so what will happen? So here the double bond is there, right? So one of the bond will break. So one electron will come over here, one electron will come over here. So here also there are two hydrogen atoms are there. One hydrogen we have to attach it with this hydrogen, this carbon, and another hydrogen we have to attach with this carbon. So it forms the ethane. So ethene is converted it into the ethane. So alkene we are converted it into the alkane. Suppose if you are taking the propene. So propene formula is CH2 double bond CH CH3 plus H2. So nickel we are using as a catalyst over here. So one hydrogen will add over here and one hydrogen will add over here. So we have to remove the double bond. So CH3, CH2, then CH3. So we have added one hydrogen over here, so that's why it's become CH3. One hydrogen over here, so it becomes a CH2 and CH3. So propene becomes the propane. Okay. So the addition of the hydrogen to the unsaturated hydrocarbons to form the saturated hydrocarbons, we call this reaction as hydrogenation. Adding hydrogen to the reactants, we call it as a hydrogenation. So hydrogenation is used to convert the unsaturated oils and the fats to the saturated oils and fats. Okay, so where is the application for this hydrogenation is? So we are getting the oil from the sunflower or rice bran something, so that oil contains the more than one double bond. So if we are consuming the oil with the double bonds, there are so many reactions will takes place in our body. So what they will do is they will do the hydrogenation reaction for the unsaturated oils and the fats, so it becomes the saturated one. So this process, this hydrogenation, we are using for the to prepare the saturated oils and the fats. Next one is the substitution reaction. So substitution reaction is nothing but usually the saturated, the alkanes will undergo this reaction. Why the alkanes will undergo the substitution? Why not the addition reaction? Because the alkanes already saturated with four different atoms. So four different atoms, hydrogens are present over here. So there is a no more bond to break and it cannot able to add the any atom over here. So because of this reason, so it will replace the one atom and it is substituted in that place. So that's why the alkanes are undergoing the substitution reaction. Saturated hydrocarbons undergo the substitution reactions with halogens to form the substitution products. So here, this is single bond C is there, only one carbon atom is there. So we call it as a methane, and we are treating it with the Cl2. Okay, so one of the important for this reaction is always the alkanes reacts with the chlorine in the presence of the sunlight. We have to write over here sunlight. That is a very important. So methane reacts with chlorine in the presence of the sunlight. So one of the hydrogen, so there are four hydrogen atoms are present over here. So one of the hydrogen atom we are replaced by the one chlorine atom over here. So CH3Cl. Here four hydrogen atoms are there. So we are writing H3 and one more chlorine atom we have written over here. Plus here the left out one chlorine atom is present and one hydrogen is over here. So that hydrogen, this chlorine forms the HCl. So this is the byproduct. So the name of this compound CH3Cl is chloromethane. So we have already seen yesterday. So the halogenoalkanes. So in the halogenoalkanes, the halogen is present over here. So the name of the halogen is chlorine. So we call it as chloro, and one carbon atom is present. So it's a methane. So chloromethane. So again, what will happen is this chloromethane, if there are more chlorine molecules are present, again, why we are writing the Cl2? Why we are not writing the chlorine Cl atom? Because the chlorine is the diatomic molecule. It always occurs in the nature as Cl2. So that's why we are writing Cl2 instead of Cl. CH3Cl, and again if you are having a more chlorine molecules, so again, so in here three hydrogen atoms are there. One of the hydrogen is replaced again with one more chlorine atom here. So CH3 becomes a CH2 and one more chlorine atom we have to add up over here, CH2, Cl2 plus HCl. Again, if more chlorine are present, so this we call it as a dichloromethane. There are two chlorine atoms are present in this. So we call it as a dichloro. One carbon atom is present, so methane. So dichloromethane. Now, this dichloromethane, again, if it reacts with the one more chlorine molecule, so here one of the hydrogen atom again replaced it with the chlorine. So here there are two hydrogen atoms are present. So one hydrogen is replaced with the one chlorine atom. So it becomes the CHCl3. and one the hydrogen and one chlorine will forms the HCl. So there are three chlorine atoms are present in this compound. So trichloromethane. Trichloromethane. So this trichloromethane, the other name for the trichloromethane is chloroform. So the chloroform we are using in the day-to-day life. So this chloroform is used as a solvent actually. So it can able to dissolve so many organic compounds. So it is used in the more laboratory and all. So the chloroform, the trichloromethane, again if you are treating it with the one more chlorine molecule, this hydrogen is replaced with the one more chlorine. So it becomes the CCl4. So this we call it as a tetrachloromethane. So because tetra means 4, so 4 chlorine atoms are present. So tetrachloro, one carbon atom is present. So methane, tetrachloromethane plus HCl. So this substitution reaction occurs only in the presence of the sunlight. So if we are not stop the reaction, so all the hydrogen atoms of the alkene molecule are replaced it with the chlorine atoms. Now, next one is some important carbon compounds. So ethanol. So from the name itself, we know that ethanol, OL. So the OL indicates the alcohol. The OH group is present. So there are two carbon atoms are there. So we call it as ethyl alcohol. Okay. So what are all the properties of the ethanol is? It's a colorless liquid and it's having a pleasant smell and also it will burn very well. So that's why we are using in the uh, spritz lamps. So it is easily soluble in the water. It's easily soluble in the water in all the proportions, and also it is acting as a good solvent. And the ethanol reacts with the sodium. Okay, so why? Because sodium is the reactive metal. So the ethanol reacts with the sodium and it forms the sodium ethoxide and hydrogen gas. Why? Because here the hydrogen is easily replaced it with the sodium atom. So what we have to do is we have to write C2H5OH. So in the place of the hydrogen, we have to write the Na. So C2H5ONa. And one molecule of the ethanol will give you the one hydrogen atom. Okay, but hydrogen is a diatomic molecule, so it is H2 only we have to write it. So H2 means, so we have to balance the equation by 2 over here. So 2C2H5OH will give you the 2 hydrogen atoms. So H2, and here also we have to write 2C2H5ONa. So balance the equation by Na also by 2. So how to name this compound? So sodium atom is present. So sodium, this is the eth. There are two carbon atoms are present. So this is the eth and the oxygen is present. So oxide, sodium ethoxide. Okay, so how will you confirm that the reaction is going on? So the hydrogen is a gas. So it will give the bubbles. So from that we can able to identify that. So the reaction is going on. So the next reaction is ethanol reacts with concentrated sulfur H2SO4 is nothing but sulfuric acid. So it forms the ethene under the water. Okay, so what is the role of the sulfuric acid? So it is used as a dehydrating agent. What is meant by dehydrating agent is it removes water from the molecule. Okay, so how to remove the water from this one? So I'll just write over here the structure of the ethanol. So C H3 CH2OH. So now when you are treating it with the H2SO4, the one water molecule we have to remove it. So there are two carbon atoms are present. So from this carbon atom we are removing the one OH. Okay, I'll just write like this way. Okay, not able to. Okay. 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 So I'll just write like this way: hydrogen, hydrogen, and one more hydrogen here. So this carbon will give you the OH and this carbon will give you the OH. So H and the OH will form the water molecule. And remaining thing is here CH2 double bond CH2. So like this we have to write it. So concentrated H2SO4, it can able to remove the water from the compound. It forms the ethene. So alcohol will be converted it into the ethene plus water. So what are all the uses of the ethanol? So ethanol is used for making the alcoholic drinks, and also it's a very good solvent. It can able to dissolve so many organic compounds, and it is particularly we are using in the chromatography and gas liquid chromatography and so many spectroscopic studies and all. We can able to use this ethanol as a solvent because it is easily evaporate, and also it is used for making the medicines like tincture iodine, cough syrups and the tonics, etc. Okay. So properties, it is a next one is the ethanoic acid. So from the name itself we can able to identify acid means it's a COOH group is there. So eth, so it contains the two carbon atoms. So CH3COOH. The other name for the ethanoic acid is acetic acid. So the properties, so the again the ethanoic acid is the colorless liquid with a pungent smell and the sour taste. So it is easily soluble in the water, and here solution of the 5 to 8 percentage ethanoic acid in water we call it as a vinegar. Okay, so the vinegar we are using in the day-to-day life as a preservative in pickles and all we will be using food and all, because if the in the food mainly the pickles it contains the oil, so we have to preserve it for the long duration. So if the oil is there it will easily oxidized and it becomes a rancid. So to avoid that we have to add the vinegar. It is acting as a preservative. It will avoid the oxidation of the oils in present in the pickle. So esterification reaction, one of the important reaction. So ester. So we are forming the ester from the alcohol and the acid. So ethanoic acid reacts with the ethanol to form the ester. The name of the ester we call it as ethyl ethanoate in the presence of the concentrated sulfuric acid. So ethanoic acid, the formula is there are two carbon atoms we have to write it. Acid is COOH, CH3 we have to write it because we have to make the two carbon atoms. It's ethanoic acid plus ethanol. So ethanol, the OL indicates the OH, the alcohol group, and there are two carbon atoms, so C2H5OH, ethanol. So again, we are using the concentrated sulfuric acid. So we know that we have to remove the water molecule from these two reactants. Okay. So how to remove the water molecule is, so we have to take the OH from the carboxylic acid and H from the alcohol. So we will be getting the H2O here. See, so now we have to write like this way. So CH3CO is there, CH3CO. We have to write CH3CO. In organic chemistry, we have to write where the bond is breaking, there only we have to form the bond. So in this case, CH3, here the bond is breaking and here the bond is breaking. So we should not write CH3CO, C2H5O. That is a wrong way. So the bond is breaking over here. That has to be combined with where the bond is breaking over here in the next one. So CH3CO, we have to write like this, CH3CO. Then here the hydrogen only we have removed. The oxygen is there. So we have to write the oxygen, then the backwards we have to write it oxygen, then C2H5, oxygen, then C2H5. So plus water. So the name of the ester is ethyl ethanoate. So when the acid and the alcohols, when we are combining in the presence of the concentrated sulfuric acid, so we will be getting the ester. It's very sweet smelling, pleasant liquid. This reaction we call it as esterification reaction, one of the important reaction. The next one is the saponification reaction. So what is the saponification? So whenever the ester it is reacts with the sodium hydroxide, so we will be getting the sodium salt of the carboxylic acid. So that we call it as a saponification reactions. For example, so the ethyl ethanoate. So the same formula CH3CO over C2H5, CH3CO over C2H5, ethyl ethanoate. We are treating it with the sodium hydroxide. Okay. So now what will happen over here is, so the bond will break over here. Um, okay. So now here we have to break a bond. So the ONA, we have to attach it with the CO group. So it forms the CH3COONA and C2H5OH like this. So we are getting the ethanol as a one of the product. So actually in the place of the Na, if you are having the hydrogen, then that we call it as a acid. COOH is the acid. But here the sodium is there. So what we have to say is sodium acetate or sodium ethanoate, we can say. Both are same only. So acetate is the actually the common name, or sodium ethanoate also we can say. So again I'm saying, so CH3CO over C2H5, the bond will be breaking in between the two oxygen atom. So the ONA will be attached with this CO group and it forms the carboxylic acid, sodium salt of the carboxylic acid, and the ethanol will be forming. The alcohol is the another product. Next, the ethanoic acid can able to react with the base. Yes. So this is the neutralization reaction. We call it as because when the acid reacts with the bases, usually we will be getting the salt and the water. So CH3COOH reacts with the NaOH. So we will be getting, so again, the water will be formed. So here the hydrogen and this OH will be removed. So CH, so this hydrogen and this. So in the place of the hydrogen, the Na we have to substitute CH3COONe plus water. So in the saponification reaction, we will be getting the ethanol as the product. In the neutralization reaction, we are getting the H2O. But in both of the reactions, we are having the same product, sodium acetate or sodium ethanoate. So the next one reaction is ethanoic acid reacts with the carbonates and the hydrogen carbonates to form the salt, water and the carbon dioxide. So whenever we are treating the carbonates, so immediately we will be getting the carbon dioxide is one of the product. So carbonates. So if it is either the carbonates or hydrogen carbonate. So both the carbonates we will be getting the carbonates as one of the product. So CH3COOH acid, when we are treating it with the Na2CO3, so one of the carbon dioxide. So here the CO3 is there, right? So the CO2 will be removed and in the place of the hydrogen we are substituting the Na. So CH3COONa plus water we are writing. Okay, how to balance the equation is, here there are two sodium atoms are present. So but here only one hydrogen is present. So that's why we are writing 2 over here to balance the to balance the sodium atom. So CH3COONa, so 2 here also the 2 plus H2O, because the one molecule of the acid will give you the one hydrogen. So here the two molecules are there, right? So it will give the two hydrogen atom and one more oxygen is left out over here because out of CO3 we are getting a CO2 only. So one oxygen is left, that oxygen will combine with the H2 and forms the water. So again the product is sodium acetate plus water plus carbon dioxide. So the difference between the NaOH and the Na2CO3 is in the NaOH we will be getting only the water molecule, but in the carbonate reaction apart from the water we are having one more gas CO2 we will be getting. So in this reaction we will be getting the bubbles. So the bubbles indicates that the carbon dioxide gas is released from the reaction. CH3COOH plus NaHCO3. So this we call it as sodium hydrogen carbonate. So this is sodium only, the atoms are there. Here only one sodium atom we have to write it plus hydrogen. So NaHCO3, sodium hydrogen carbonate. So from the carbonate we will be getting the CO2 gas, and in the place of the hydrogen we are substituting the Na. So CH3COONA, and here one hydrogen atom is there and here one hydrogen atom and here one oxygen, that forms the water. So we need not balance the equation over here. Everything is balanced. But previous case only, so we have to balance the equation by 2. The next one is the soaps and the detergents. Okay, so as a day-to-day life, we are using the soaps and the detergents. So what is a soap basically? So what is the detergent? So soaps are the long chain sodium or the potassium salts of the carboxylic acids. Okay, so sodium stearate. Stearate is nothing but that it contains the C17 carbon atoms. Okay, see for example, C18 carbon atoms, that we call it as a stearic acid. So C17 here one carbon atom, so totally C18 carbon atoms present. So C17H35 COONA. So we the sodium atom is present, so we call it as sodium stearate. So now this is the structure of the soap molecule. So C17 means, so like this we are drawing. Okay, so C17 like this. So this we call it as a, so we have to write like this way. CH3, CH2, CH2, CH2. So like this we have to write for up to the C17. So instead of writing like this, we are just making a up and down arrow marks like this, chains. So it has the two parts. So CH3COONA is having the two part. The one is the long hydrocarbon chain. It contains only the hydrocarbons. There is a no more atoms or oxygen or sodium or nothing is present. Only the carbon and the hydrogen. So long hydrocarbon part is present, and the this is the hydrophobic. Okay, what phobia means? It's a fear. Hydro means water. So the long hydrocarbon chain is having a, it's a water repelling group. Repelling means it does not want to make a bond with the water. That's why it's a hydrophobic. But it can easily soluble in the oil. The long chain hydrocarbon, it is easily soluble in the oil, but it is insoluble in the water. So that's why we call it as hydrophobic. And the grease. So usually, so why we are using the soaps and detergents? Because usually the oils and all will fall on our dresses. So we will get the dirt over there. So the dirt usually contains the oily substances. So that oil substances we have to remove from the cloth. So if you are applying the water, it will not go. So once you place the soap water or something, immediately it will go, because this long chain hydrocarbon is soluble in the oil or the grease. So it will make the grease which is present in our cloth, it will make soluble over there and it will try to remove it from the cloth. So that is why in the soap we are using the long hydrocarbon chain. Okay, the next one is the short ionic part. Okay, where is the short ionic part is present? This one. So this one. COO minus and Na plus. So why we are writing Na plus? Because always the metals are having the positive charge. The sodium is present in the group 1, so it's having a positive 1 charge. So COO minus. This is the counter ion for the COO minus and the Na plus. So this contains the ions minus plus. So that's why we call it as an ionic part. And this is the one which is a hydrophilic. Philic means it's liking. It can able to attracting. So this is hydro means water. So this is the water attracting group. See, because if the soap, if it fully contains the hydrocarbon chain, it does not soluble in the water. So we have to make the soluble in the water, then only we can able to remove the grease. So that is why we have given the short chain. So this will dissolve in the water. So the role of the COO-Na is making the soap to dissolve in the water. That's why we are having the COO minus and the Na plus, the ionic part. But at the same time, that this part cannot able to remove the oil or the grease because it is insoluble. Now, the cleansing action of the soap. Okay, so now we are going to see how this soap molecules removing the dirt from the cloth. When the soap is dissolved in the water, it forms the spherical structures called the micelles. So see like this. So now we have added the in the water we have added the soap molecules. So this is the long hydrocarbon chain and this is the COO minus and the Na plus. So like this it will form the spherical structure. So this we call it as a micelles. So the long hydrocarbon chain and COO minus Na plus. So then in each micelle, the soap molecules are arranged radially such that the hydrocarbon, Hc means hydrocarbon part is towards the center. See all the negative signs are the outside, the hydrocarbon chains and all inside. Because why it's forming like this is, suppose if the dirt is here, if the dirt is here. So all the hydrocarbons can able to remove the dirt from the cloth. That is why all the hydrocarbon chains and all facing towards the center of the point. So towards the center and the ionic part is towards the outside. So the hydrocarbon part, so what it will do, so suppose if the, so see here, suppose the grease is over here. All the hydrocarbons are trying to remove the grease from the cloth. So and forms the emulsion at the center of the micelles and can be, so when we are rubbing the cloth using the soap water, so using the hydrocarbons will remove the grease from the shirt, and when we are washing it up everything will be going away from the shirt or something, so the cloth will be free of the dirt or the grease. So this hydrocarbon chain making the dirt soluble in that and it is removing from the cloth and that's making the cloth free from the dirt. So here, so this is the cleansing action of the soap. So see here, so it's forming the micelle. This we call it as a micelle formation. So all the hydrocarbon chains are focusing at the center. All the ionic parts are at the towards it. It's just facing outside, because its job is to just make the soap dissolves in the water. That's all. So now here water is there. So now this is the dirt. All the hydrocarbon chains, it's just making soluble the dirt. So all the hydrocarbon chains and all making to remove the grease from the cloth and it's just removing. So when we are adding the more water, so the dirt will be moving from our cloth. Detergents. So detergents, so now till now we have seen the soap. So what is a detergent? So detergent are also the same thing. Long chain the sodium salts of sulfonic acid. Here some of the atoms we have replaced it. That's all. So that makes the detergents. So the soaps do not wash very well with the hot water. Okay, what does mean by the hot water? Hot water means it contains the insoluble salts. calcium 2 plus and the magnesium 2 plus ions will be present in the water. That makes the water hard. So we cannot able to make the soap soluble in that because already the calcium magnesium salts are present, so it will not allow the soap to dissolve. So because it forms the insoluble precipitates of the calcium and magnesium salts in the hard water. But the detergents are having a special group such as the sulfonic acids group. So sulfonic acid, the formula is SO3H. So this sulfonic acid is present in the detergents. So this makes the detergent easily wash well with the hard water because it does not form any insoluble precipitates of the calcium and magnesium which is present in the hard water. So this makes the difference. So the sulfonic acid is present in the detergent that makes the detergent soluble in the water, but that is absent in the soap. That's why it's making a precipitate with the calcium and the magnesium. So the next one is the differences between the soaps and the detergents. So the soaps are nothing but the sodium salts of the fatty acids. So the detergents are nothing but the sodium salts of the sulfonic acids. Soaps clean well in the soft water but do not clean well in the hot water. So we have to make the soap so much we have to waste it in the hot water. But the detergents are not like that. It will easily clean well with both hot and the soft water because of the presence of the sulfonic acids. Soaps do not clean as well as the detergents, but the detergents clean better than the soaps. So the detergents are very good compared to that of the soaps. Soaps are biodegradable and do not cause pollution. But the detergents are having a disadvantage over here. Some detergents are non-biodegradable. So what is mean by biodegradable? Biodegradable means, so it's getting degradation. For example, so if you are using the bio means it's a microorganisms, either the what is that bacteria or the fungi can easily decompose the particular compound that we call it as biodegradable. Non-biodegradable means it persists in the earth more time. Say for example, if the soaps can exist for 2 or 3 days, but the detergents will exist for 1 year. So if it exists 1 year as in the same molecular formula, it may react with some other compounds and it will lead to some other products. So that's why we call it as a non-biodegradable, and definitely it will cause the pollutions to our earth.